Welcome to our sixth lesson in statistics, where we'll discuss how to determine the most appropriate measure of central tendency. In this lesson, you'll learn to distinguish the best measure of central tendency based on data type. By the end, you'll be able to interpret various scenarios, handle special cases like outliers, and confidently decide whether mean, median, or mode offers the best summary for a dataset. When selecting the best measure of central tendency, first we identify how the data is measured. Nominal and ordinal data often call for simpler methods, while interval and ratio data can handle more complex approaches. We will discuss each during this lesson. Nominal data are purely categorical and do not have any inherent order, so we cannot perform quantitative calculations like finding an average. Instead, we focus on frequency counts or the mode, which identifies the most commonly occurring category. For example, if we have categories like red, green, blue, the mode tells us which color appears most frequently, making it the best measure of central tendency. Ordinal data have a ranking or order, but the distances between ranks are not necessarily equal. That means someone who ranks first is above second, but the gap may not be the same as between second and third. In this context, the median is typically more meaningful than the mean because it represents the middle rank. The mode may also be helpful for seeing which rank is most common. Interval data have consistent intervals between values but do not have a true 0 point, meaning 0 on the scale doesn't indicate an absence of the quantity. Temperature in Celsius is a good example of this. 20 degrees Celsius is not twice as warm as 10 degrees Celsius, and 0 degrees Celsius does not mean that there is no temperature there. Both mean and median can be used effectively, but the lack of a true 0 means ratio comparisons like doubling and halving do not hold. Ratio data share the same characteristics as interval data, but they have a meaningful 0, which indicates the complete absence of whatever is being measured. This property allows meaningful multiplicative comparisons. For instance, a weight of 10 kilograms is truly half of 20 kilograms. Since ratio data can accommodate the full range of mathematical operations, the mean is often a valid measure, provided there are no major outliers. Now let's see how extreme values or outliers affect the measures of central tendency. When a dataset has outliers, the mean can shift dramatically. Remember our earlier explanation of the mean as sharing snacks equally among friends? Imagine one friend is extremely rich and brings an excessive number of snacks, so many that when everything is shared, everyone ends up with way more than usual. This distorts the mean, making it no longer a true reflection of the center. The median, however, is more resistant to outliers, since it simply identifies the middle position. That extremely rich friend will be at the top of the list, but won't affect the central value. The mode might stay the same unless the outlier appears frequently enough to create a new most common value. This is why the median is often preferred in datasets with extreme values. Now let's talk about repeating values. When a value appears frequently, the mode highlights it as the most common observation. The median still divides the dataset in half and stays mostly unaffected, unless many repeated values cluster near the middle, potentially shifting it. The mean can be pulled toward a highly repetitive value, especially if it makes up a large portion of the dataset. This can skew the mean, making it closer to that frequent value. Now let's look at some examples to understand these concepts better. A survey on favorite fruits among 100 people was conducted, and the following fruits were named: apple, mango, banana, grape. Which measure of central tendency is best to use? From the problem, we can see that this will be nominal data, since people are simply choosing which favorite fruit without any rank or numeric score. The mean or median is meaningless here because we can't average categories. Instead, the mode is the best measure to identify which fruit is most preferred by the majority. This gives a clear picture of the most popular category. Example 2. A satisfaction survey was conducted by a local grocery with responses about the service ranging from very dissatisfied to very satisfied. Should we use the mean, median, or mode as the measure of central tendency? This data is ordinal because the responses can be ranked, but the distance between very dissatisfied and dissatisfied isn't necessarily the same as between satisfied and very satisfied. The mean doesn't make sense here because the spacing isn't uniform. The median is most suitable, capturing the middle level of satisfaction, while the mode tells us which specific response is chosen most often. Example 3. The average daily temperature in degrees Celsius is measured over 30 days. How do we decide whether to use the mean or median? Because temperature data in Celsius is interval, 0 is arbitrary. It doesn't mean no temperature. Generally, we can use mean if the temperature readings are fairly consistent, without large spikes. However, if there's a sudden cold snap or heat wave, the distribution might skew. In that case, checking the median might provide a more stable indication of typical daily temperature. Here is example 4. A list of student weights in kilograms is measured for a class. The following values were recorded: 45, 50, 60, 65, 70, 70, and 90. How do we choose the most appropriate measure of central tendency? These weights are ratio data because 0 kilograms would represent no weight at all, allowing valid statements like twice as heavy. In most cases, the mean is appropriate since we can perform full arithmetic operations on ratio data. However, note the outlier at 90 kilograms might pull the average up. If we believe this outlier misrepresents the typical weight, the median may be a better choice. In this lesson, we learned about different types of data and how they influence the choice of central tendency. Nominal data consists of categories without order, so the mode is the only meaningful measure. Ordinal data has rankings, but uneven gaps between values, making the median the best option. Interval data is numerical with equal spacing but no true zero, so both mean and median can be used. Ratio data includes a true zero, allowing for full mathematical operations, making the mean the preferred choice. We also learn of how outliers affect central tendency. Extreme values can distort the mean, but the median remains stable, and the mode only changes if the outlier appears frequently. Similarly, we discussed how repeated values can pull the mean closer to the frequent number, while the mode identifies it directly and the median remains largely unaffected. Finally, we learn how to choose the right measure of central tendency based on the dataset. Understanding these differences helps ensure we use the most accurate method for summarizing and interpreting data. Thank you for joining me in this lesson. Remember, you can find this content and additional resources on the website linked in the description. If you have any questions, feel free to ask and I'll be happy to help. See you in the next lesson where we will discuss the measures of dispersion.